Difficulties.
All right, great.
You're on.
All right, good afternoon and welcome to this joint hearing of the House Environment and Energy Committee and the House Transportation Committee on this first day of the new session. It's great to see everyone. And I just want to give a shout out to our staff for having made this logistical leap on the very first day of session. And sorry for the delay, but here we are in a different location. So we are going to come together and hear from our state climatologist to kick off the afternoon's testimony. And the overall heading is post kind of the flooding, but also understanding climate change in Vermont, putting it into context and understanding our respective agencies' response, both to the floods, but also to climate change more broadly. So with that,
I just want to add, I think Chair Sheldon and I thought this would be a really great opportunity for our committees to be in the same space together to learn from each other, because I think we have different perspectives on some of these issues. And so I just know I'm really looking forward to the afternoon and to returning again on Friday to do this work. So thanks everybody for doing a kind of more complicated first day back, but nobody's new anymore. So we thought you would all be up for it. So thanks in advance.
all right, and with that, I'd love to introduce Dr. Leslie Ann Dupuini-Giroux. I hope I got that close enough. Our state climatologist, who's joining us via Zoom as our first witness. Welcome.
Thank you, Chair Sheldon, and Happy New Year 2024 to everybody. Thank you for the invitation to be here. Let me try and get all set here. I have screen sharing, but it says it's disabled right now.
Well, you're going to make her a co-host. There we go.
Okay.
This is the same guy that was downstairs at the door.
Great. Yes, we can see your screen now.
Okay, perfect. And I can still see you in the corner here. All right, so thank you again to both committees for the invitation to come on the very first day of our legislative session and talk a little bit about weather, climate, and climate change for the state of Vermont. And what I'm going to try to do is to do a sort of big picture piece, but also tie it into a lot of the events that we saw last year in 2023, so that we're all on the same page with why these events are occurring, why the frequencies, the durations are occurring, and then end a little bit with some of the things that we can do in this particular space here, in this particular session. So for today, what we're going to look at are some of the hazards that we've been experiencing, flooding, droughts, and so on, but also putting it in the context of climate change and looking at it through the lenses of who is vulnerable, who needs to be part of that conversation, what are some of the sectors of our economy as a state that we need to have front and center, and then what is it about our landscape that makes us more vulnerable in certain parts versus others. So those are some of the themes that are going to be running through as we step through and chat today. So just to make sure that we are looking at all sectors, who is vulnerable to weather, climate, and climate change? Well, some of the sectors that are particularly at risk, that are particularly exposed, include our various elements of our infrastructure. So that includes our roads, but also includes our electrical grid. It includes our critical facilities. It includes various aspects of emergency management from the state level all the way down to the town and the municipal level. It affects us as human beings, so various aspects of our human health are also at risk. And then parts of our economy in terms of our forestry sectors, in terms of our agricultural sectors, tourism and recreation are also things that we're looking at in looking at the vulnerability to our changing climate. So when we talk about hazards, what are some of the hazards that are particularly observed across the state? And you'll notice right off the bat that the ones that we think about first are flooding, for example, and then the flip side of the coin, droughts. But we can't forget about winter storms, whether it's snowstorms, whether it's ice storms. We can't forget about those very, very heavy rainfall occurrences that occur during the summertime. Wildfires have been with us for decades. They were particularly bad in 2023, so we'll talk about that. They had elements of air pollution that affect us as human beings, but are also part of the challenges for the landscape. And then when we think about temperature, we have very cold conditions, which are becoming less frequent, but they're still there. And the flip side of that are very hot days, which are also important for us for a number of different reasons. Winds are something that we don't always think about. And when we're talking about winds, we're looking at whether they are very concentrated winds, whether they're very fast. We hear about wind gusts. Sometimes there's fast as hurricane force wind gusts. And so bringing wind and moving air into the equation. And then because we're such a mountainous state, we can see winds that tend to occur on one side of our mountains, very fast flowing winds, and we call those shirkshas. So these are another piece of what we're looking at in here. And then
I think we all just learned a word. Excuse me.
Oh, did you?
Yeah.
There's going to be a quiz at the end of this. Make sure you spell it right.
We're in school.
There we go. So the last part in here are as the temperatures warm and the ecosystems and natural habitats change, we have more increases in terms of the insects that are invasive species or that are populations are booming, for example, and other types of disease. So we've got the biotic or the biological pieces of what we're at risk for. So these are some that I've sort of gone through over the years and compiled into this list so that we have it all in one place. So as you're looking at this and you're thinking about how much damage, economic damage occurs as a result of any one of those hazards, this graph that you're seeing here shows you the billion-dollar disasters across the entire United States, starting in 1980 and going up until last year. And each one of these colors represents a certain type of hazard that caused at least $1 billion worth of disaster. So you see things like the wildfires, you see the winter storms and so on. And a couple of things that you're noticing right off the bat is that the number of these hazards and disasters has been increasing, but also the price tag has also been increasing. So you're seeing more and more costly hazards. So this is across the entire US. The other thing that you're seeing here that might surprise you is you see these green bars. Those green bars are the ones that are the highest type of hazard contributing to these billion-dollar disasters. And you may be surprised that it's not hurricanes or tropical cyclones. It's actually those severe storms. So the summertime convective type storms are actually the ones that produce most of the billion-dollar disasters across the entire US. So that's another piece that we're sort of thinking about here as we put all of this into context. So that begs the question, why is Vermont so hazard prone? And are there places across the state that are more hazard prone than others? And then what can we sort of do about this? So the big answer in terms of why we're so hazard prone is our physical geography. And what this upper diagram here shows us is the Green Mountains, the spine of the Greens that we see here, are a continuation of the Appalachian Mountains, which also continue into the White Mountains in New Hampshire as well. So this very steep topography is a large reason why we have so much hazard proneness in another word. And so it sets up conditions for very heavy rainfall because as air rises, it produces more rainfall than if the land was just flat like this. And having these mountains also sets up conditions where sometimes you get snowfall on one side of that Appalachian Green Mountain, White Mountains. You get snowfall on one side and you might get icing on the other side. So knowing that our topography is critically important allows us to understand why we're so much at risk. So if we think back to 10th of July last year, 2023, that topography piece comes back in here. So this is a satellite shot showing you all of those storm systems that, you know, span 9th, 10th, and 11th of July 2023. And as you're looking at it in here, you're seeing that a lot of those central parts of the state, there was a sort of concentration of all of those storm systems. So lots of rain concentrated and pouring out in the central part of the state itself. And you're seeing a lot of moisture coming in from the Atlantic, which helped to fuel all of those storms. You had some other storm systems or low pressures coming in towards us from the west, and all of those sort of meeting over us here. And then the last thing I wanted to point out to you as this loop plays, what you'll see is, if you look really closely, you'll see the effect of wildfires coming in. See that? Everybody see that? Right. Yeah. So there's some wildfires, the smoke hadn't gone away, even though we're in the middle of all of those flooding conditions. So as we're thinking about this, as part of the reason why I'm putting all of these hazards on the table, because we can have multiple hazards and multiple risks going on at the same time. So that was last year. If we go back 12 years to Irene, which is one of our markers, again, we're seeing the influence of a tropical system moving northward across the state, going over some very, very complex terrain, very, very complex mountain systems, the tectonics down the southern part of the state, and giving us a tremendous amount of damage, including some of the infrastructure damage that we've seen, unfortunate loss of businesses, unfortunate loss of agricultural produce, because whenever floodwaters touch crops, they have to be destroyed, disposed of, because the floodwaters can contain contaminants. And so we don't want that to be consumed by us as human beings. Loss of village centers, loss of individual properties. Those are some of the very, very sad images that we saw post-Irene. And again, bridges, other sorts of infrastructure also being destroyed. If you keep going back in time, what you're seeing here is a map that was created by Jonathan Croft of VTrans that showed all of the roads that were closed at one point in time during or just after Irene. And those are these colors. Can everybody see the colors okay? So you're seeing some yellows and some greens and some reds. Those are road closures. And what he did was he superimposed your Irene closures on top of the damages from the 1927 flood. And they match up perfectly, right? Because the roads have not moved since the 1927 flood. And so in Irene, and again in last year's flood, you're seeing that perfect match of where there tends to be this proneness to having or road infrastructure being damaged. So here's a blow up of the central part of our state. And again, you're seeing the Irene floods in here. Those are those colors. And the black lines are the 1927 floods in here. Okay, so this is I like this because what it allows us to do is to see exactly where possibly in the future you'll have yet another set of damage because of that the relationship between your roads and your rivers, particularly where they've been affected in the past. So one way of saying that is that they're next to each other. Sometimes they're a couple of feet away. And that's what we're seeing across in here. There's some places where your roads and your rivers are so close that repeat flooding tends to occur. So one route is Route 100. Another place is the Jay Peak region, where we see a lot of that sort of coming together, sort of Montgomery region of the state, just south of Jay Peak across in here. And on the left-hand side, you're seeing that same sort of relationship in the Waterbury area, where you've got I-89, which is this blue line here, and we've got the Winooski River, and the way in which all of these sort of come together and get pinched off if the Winooski overflows its banks, which is what happened during Irene itself. So we're looking to see where those pinch points literally are across in this region in here. So topography is important for roads, topography is important for floods, but it's also important for air quality. And that's because when you have mountains and valleys, if you have a lot of pollutants in the atmosphere, if you have a lot of smoke, whether it's wildfire smoke, whether it's other type of burning, and it tends to collect in the valleys, what that sets up is very poor air quality conditions and has the potential to sort of trigger a lot of human health implications as a result. So air quality is directly related to where our mountains and our valleys also occur. So this is a shot, another satellite shot from exactly a week after the historic floods on the 10th of July, 2023. And you're seeing again the very extensive nature of all of those wildfire plumes and smoke that made their way down, not just across Vermont and New Hampshire, Massachusetts, but all the way down to New York and DC and so on. So we're looking at that relationship in here. The other piece that's important that we've also seen in terms of air quality is there are times when there is a lot of pollution in the air that triggers an air quality alert that says, okay, if you have a respiratory ailment, please stay inside. Or if you are exercising, try to do so either early in the day or late in the day. So that, of course, is related to smog. And as we're looking at it, we saw that really, really clearly during the COVID pandemic, when, if you remember, we went into a lockdown. And so industrial production ceased. We weren't driving. And so what we saw was this dramatic decrease in smog conditions because the materials that got used to create the smog were actually less. And so this is a sort of average of what traditional or typical conditions look like across most of the Northeast. And this is what it looks like. It looked like during the pandemic when everything shut down. So the gas that we're looking at here from an air quality perspective is ozone. And ozone is being monitored in a couple places across the state. It's being monitored in the north, which are these green lines here. And it's also being monitored in the south, which are these blue lines here. And you see that the amount of ozone, the amount that sort of triggers your smog alerts tends to be higher in the southern part of the state than it is in the northern part of the state. So having these measurements allows us to sort of understand where across our geography is particularly at risk. Now, smog is one piece that we're looking at, but then if we expand this a little bit, what else can we talk about human health-wise? We can see some things in here. So folks always used to ask me, well, what about Lyme disease? And I was never able to have a really, really good answer until we finally had this, this product that came out that talks about where the Lyme disease cases were being reported. And so as you look at this, you see this dramatic amount of increase in Lyme disease cases being reported across the Northeast, including Vermont. So you see this massive explosion of cases in 2018 versus 1996 as one of those things that we're looking at from a human health perspective. Now, the other thing that we're also going to be looking at is high temperatures. And so whenever we hear those alerts, it's going to be a hot day, it's going to be a heat wave, please stay inside. What we're looking at is temperatures that are more conducive to us here in the Northeast, 87 degrees Fahrenheit, because as Northeasterners, as Vermonters, we are not as acclimated to the higher temperatures in 90 degrees and 95 degrees that you tend to see in the southern states. So when you hear a heat alert going out, it's 87 degrees. And this was some work that was done by one of my postdocs, Dr. Evan Oswald, in conjunction with the Vermont Department of Health about 10 years ago. So let's talk about temperatures a little bit more. And we're doing it both from a high temperature as well as a cold temperature because they're both equally important. So exactly 1 year ago, January of 2023, that January was actually the warmest January since we started keeping records in 1895.
Yeah.
And so as we're seeing this here, that's another clear indication of how our planet continues to warm, because we're seeing our wintertime temperatures exceeding values that they've never exceeded before. So January 2023 was the warmest January since 1895. So if you're wondering, how can we bring this a little bit closer to home? So there's a product called the Climate Explorer, the Climate Resilience Toolkit, that allows us to actually experiment with and explore what climate change looks like on a zip code level. So I believe everybody has a copy of these slides in here. So you might want to put a little star next to this one, and Google, when you put it in, go and put your own zip code in here, because what it'll allow you to do is it'll allow you to see how temperatures or precipitation or whatever else has changed over time since 1950. But more importantly, it will show you how they're going to be projected to change in the future. So as you're looking at this, the projections are these red lines and the blue lines. And the red line is projections of, in this case here, high temperatures for the day under high emissions. And then if we try to reduce emissions, what the temperatures would be in the low emissions scenario, which is this blue line across in here. So try this out, put it in your zip code. You're able to do this for everywhere across, not just the state, but also the entire nation as well. So that's temperature, usually on the high end. Let's think about what happens on low end. And one of the things that we've noticed is we're seeing temperatures, particularly in the springtime, that are what we call a backward spring or backward season, where the temperatures actually look like they're increasing and then they drop in April or May. Yeah. And when they drop, then you're also seeing things like snow falling in April, snow falling in May. You see things like killing frosts. So the plants that had started to bud are actually nipped in the bud, literally, because of these frosts. And we saw that again last year in 2023. And a lot of times when that happens, right after that, we tend to see drought conditions, which again is what we saw last year in 2023. So from an agricultural perspective, we're seeing this sort of like frost followed by drought, which is what we saw last year and the year before. And that has implications for the viability of our agricultural sector. So that's one piece that I'm sort of bringing into the equation here as we think about it from an all sector perspective here. So let's leave temperature and let's talk a little bit about moisture conditions. So the two extremes again, too much moisture, too little moisture, and then what does this mean for us? So one of the things that we are seeing with moisture, which is this lower diagram here, as our climate continues to change, one of the things that we're seeing is that there are more heavy precipitation events. So more either rainfall falling, more snowfall falling, and there are fewer events where there's light drizzle or light precipitation, right? And so this is one of the observations that we're making here from a moisture perspective. So when it plays out, what you're seeing, I purposely did not pick the 2023 because I wanted us to see that it's not just last year, but it's also a number of years that we're seeing this pattern sort of playing out. And as you're looking at this across in here, again, you're seeing right off the bat, the influence of your topography. So the highest values occurring in the highest parts of the state. And of course, this large value here is Mount Washington. So we're looking at these large events where you're getting 2, 3, 4, 5 inches of precipitation, either in a single day or in 2 or 3 days. So these multi-day events are also important here. So rainfall is only one aspect of what falls from the sky. We can also look at snowfall. And when we look at snowfall, there's a really good scale that allows us to kind of compare one against the other. So it's called the Northeast Snowfall Impact Scale. And it allows us to look at all of the massive snowfall events that have occurred across the Northeast, including Vermont, over time. And the one that still is the highest ranking one is the March of 1993 blizzard. But if you look closely, and I'm not sure how well you can see this here, but you have it on your handout, the number 4 is actually from 2 years ago. So December of 2022 was the 4th highest ranking snowfall that occurred. And you're probably like, oh, how is global warming and these excessive snowfalls taking place at the same time? And it's because we were understanding the water cycle and how it's accelerating and how you can get both heavy rainfall and heavy snowfall as our climate changes in here. So here's a zoom in of that event. And we're looking at, again, December of 2022, and across Vermont, you're seeing that most of the state actually got anywhere between 10 and 20 inches of rainfall over that entire time frame. So making sure we're looking at how these changes occur and where that vulnerability actually kind of plays out. So if you have a lot of snowfall still falling, it is going to melt at some point. And so as you look at how it's melting, what we know is that that snowmelt period is actually occurring earlier and earlier. So this is a diagram that comes out of the National Climate Assessment, the 4th National Climate Assessment. It was my privilege to be the lead author on that chapter. And so one of the things that we're seeing is that snowmelt occurring earlier and earlier, and what that means across the state itself. So that's on the wet side. That's on the extreme moisture side. At the same time, we're also seeing drought conditions. And so as you look at this diagram here, is everybody seeing these orange and browns and yellows on this part of the diagram, and then teals and greens on the lower part of the diagram? The browns and the yellows and the oranges show you when you were in drought. And the blues and the teals and the greens show you when you were in very good conditions. It starts off in 1895 and it goes down to the present. So what we're seeing is that we used to have more and very, very extreme, that's what these browns are, very, very extreme droughts. And they're still there, but they are not as long and they're not as extensive as before, because what happened is we've shifted to wetter conditions. So if I were giving this presentation 50, 60 years ago, we'd be talking more about droughts than we would be talking about floods. So that's one thing to kind of keep in mind, that floods and droughts are part of that dynamic of our state. And this diagram here shows us that floods and droughts characteristic of the state. So they're all the same except for different years. So the upper blue line here shows you the highest that Lake Champlain has ever been. The lowest green line shows you the lowest that Lake Champlain has ever been. So in other words, the driest the lake or the lowest level, the blue line is at the highest flood stage. And the red line in here shows you the median or the middle value, which leaves only one line, which is this purple line here, which is the year itself. So here's 1909, which was a dry year with some moisture in here. 1927 was also a dry year. And then we got 200% of rainfall in 2 days. And we had 1927 floods. So we went from pretty much drought to floods in 2 days. The 60s were a drought decade. They were dry decades. So you see it's tending low. And then let me move this out of the way here. This is 2011. So Irene here. So Irene set some records here that we didn't see before. The May floods also set some records that we didn't see before. Okay, so 2011, we had 2 sets of records being set due to the May floods and all that snowmelt that occurred, and then Irene came along. So what about last year as a whole. So this is 2023. And last year as a whole, you're looking at it and you're seeing the droughts that were affecting our farmers in June and into July before that tremendous amount of precipitation that set 2 new records. So this is the first wave that came down the Winooski and into Lake Champlain as a result of the 10th and the 11th flooding. And then the waters receded a little bit, and then we had more precipitation in early August. We set a new set of floods. And then if you look really, really closely, we set some floods last week. You see that? So now we have a third set of records for 2023. Okay, so we're looking at all of these levels across in here. All right, so because the state goes from droughts to floods, and we're looking at which sectors are primarily affected by drought conditions, for example, I went back to October of 2022, and these yellow lines here and the orange lines in here are showing you the extent of the drought 2 years ago, 2022, across the state itself. And what it shows you are, when these conditions occur, crops are stunted, we have fire danger being elevated, your lawns start to brown a little bit earlier, your gardens start to wilt, and those are some of the things that we observe when we have a drought. So this was 2 years ago across in here. The other thing that I wanted to kind of highlight is drought is very, very localized. And so if you look at Orange County in here, it's possible, because again, this is from October of 2022, it's possible for one part of the state one part of the county to be in drought. That's what these browns are, right? It's possible for one part of the county to be in drought and another part of the county to be moist. Why? It goes back to our topography, it goes back to our mountains and valleys and so forth. So all of this is always connected across in here. So drought, wildfires across the state, within the state, go together. And whenever we have a drought, we're always looking to see how dry it is, whether the winds are picking up. Are we going to have wildfires across the state itself? Not just the wildfires coming down from the southern part of Quebec, but wildfires within the state itself. Why? Because we've got 2 times of the year when wildfires are particularly prone: springtime and during the summer. So again, we're looking to see the connections across temperature, moisture, wildfires, forest burning, and all of the conditions that sort of go along with that. The last thing that we need to look at drought for is from an economic perspective, because droughts, when they affect our sugar maples, it affects the health and the productivity of our sugar maples. And so this is another piece as to why we need to look at drought and sort of factor that in from a socioeconomic damage perspective. So all of that was sort of wrapped up into a lot of the thinking that went into the writing of the Vermont Climate Action Plan, which of course came out of Act 153, the Global Warming Solutions Act. And that was, of course, enacted and adopted on the 1st of December 2021. And we've got just the link across in here if you'd like to take another look back through the plan itself. So in looking at the plan, in looking at all of the committees that were stood up as part of this, this particular council, the Vermont Climate Council, we had 5 subcommittees, and one of them was called the Just Transition Subcommittee. Some wonderful work that came out of this subcommittee, and it was my, again, privilege to share some of this with the National Climate Assessment as we were writing up a lot of the water chapter part of this, sharing a lot of the sort of rich resources that came out of the council into that particular realm in here. So as the House appointed member with climate change, climate expertise to the council, I was able to spearhead the writing of the climate change in Vermont section. So again, if you haven't had a chance to go through and take a look at it, a lot of the things that I'm presenting today are actually part of the council report in here. And bringing together all of the various perspectives and ways of knowing. And so Judy Dow was an Abenaki elder and scholar who was part of our agriculture and ecosystem subcommittee. And she created this diagram here to help us understand the Abenaki ways of knowing of the land and the relationship with the land. And so it was my great privilege to include Judy's diagram as part of that chapter that we're looking at in terms of climate change in Vermont. The other thing that I did was to bring all of the discussions and the subcommittees and the task groups, all of our discussions into this diagram here, which centers all of the elements of what we're looking at in terms of climate change in the state. So you see the air quality, we see our growing seasons, we see our hazards, but centering it in an equity frame, centering it in all ways of knowing, centering it in with the various challenges. So whether they are land use challenges, whether they are governance challenges, whether there are regions of Vermont that should or should not be developed, whether our infrastructure is able to support a lot of the priorities and solutions that we came up with, and making sure that all of this continues to evolve with the best science possible so that we can plan for the future in the best way possible. So this diagram, this do no harms diagram, I actually shared with the White House a couple of months ago as part of the framework for thinking about creating resilience planning across the nation itself. So in looking at one last diagram from that section, this is where we're putting all of those risks to hazards in one place and looking to see whether they are going to increase in frequency or intensity or duration, or whether they are likely to decrease, and how confident we are in those changes. So you're looking at all of the things that we've talked about so far: your droughts, your floods, your ice storms, heavy precipitation, snowfall, cold conditions, and so on. These are all part of that write-up of climate change in Vermont in the Climate Action Plan. So this plan, which was adopted, is actually featured in the 5th National Climate Assessment, which was released on the 14th of November, 2023. And in the Northeast chapter, it's wonderful to see it being pulled out here. So Vermont releases the state's first climate action plan because what the Northeast chapter is looking at is what is the progress that it is being made in the adaptation, in the resilience, in the mitigation space. And so our climate action plan was pulled up, which is very, very nice to see in here. And so all of these things that we're looking at, all of the statistics, the summary values, and so on, can be found in the state climate summary for Vermont. And again, on your hard copy, you've got the link directly to that itself. So let's head into the sort of solution space, the sort of what can we do about this. And we're going to look at this from two perspectives. We're going to look at it from a people-based perspective, and also going to look at it from a land-based perspective. So for us to really start to make progress in this, a lot of it depends on having everybody at the table from the beginning so that we can share our experiences, our knowledge, our ways of knowing, our expertise all from the beginning. This has to be a people-centered approach. So we're looking at peoples, we're looking at health, we're looking at everything from us as a society. We're looking at cultures, we're looking at linguistic pieces in here as we try to figure out what's the best way of trying to make sure that we are not leaving anybody behind. Second way that we're going to look at this is from a land-based perspective. And as we look at it, our working lands, our natural lands, our forested lands, our agricultural lands, how are they helping us both from an adaptation space, how are they helping us from a resilience space, how are they helping us from a mitigation space? And agriculture is a great example of being both mitigation as well as adaptation. And why are we sort of pulling the land-based piece out in particular? It's because our seasons are changing. And our seasons, as they change, are going to see differences and changes in our forests, in our wildlife, the snowpack, changes in our growing seasons, changes in when droughts occur. And so that focus on land, the working and natural land is one thing that we're sort of putting forward in this particular space here. The other thing that we're looking at is making sure that we elevate nature-based solutions, that we preserve parts of our landscape that we know help with ecosystem services, and also looking at ways in which, from a water-based perspective, that we're trying to slow down moving water, allow floodplains to have access to the sort of meandering that would usually occur. And so these are a couple slides from Mike Klein, who was the head of the Rivers program, and looking at what happens when we try to allow floodplains to be floodplains so that we have less damage from an infrastructure perspective, but also less damage from an ecosystem perspective in here. And so a lot of this work that Mike shared with me to help share with you today came out of Act 138 in looking at the protection of our river corridors in here. So I'm going to end with a couple recommendations, suggestions, requests. And one of them is to sort of lift up the priorities that were listed in the climate action plan. A lot of them are being implemented right now. And if there are others that could be sort of lifted up and elevated, that would be one thing in here. A lot of progress being made on two elements of the climate action plan. One is a municipal climate toolkit, which brings together all of the resources that are available that could be used on a municipal or town level, and that could be available through our regional planning commissions. And related to that is coming up with a vulnerability index to see who, what, where, and when are most vulnerable, and how does that allow us to make decisions from a resource allocation perspective and from other perspectives across in here. And then there are so many wonderful projects and priorities being implemented across all of the various agencies in the state of Vermont, all of the various commissions, all the various regional planning commissions. And so how do we support and make sure they're all interfacing and leveraging each other moving forward? And then if I had to leave one word or one phrase in here, it would be to make sure we're doing this from an all hazards perspective, from a systems perspective, so that as things tend to flip as they do across the state, we're making sure we have the resources allocated across in here. And then the last thing I'd sort of put forward is lessons learned from 2023, frost, droughts, floods. How about having a statewide summit that brings together all of the agencies that were involved, both the state of Vermont agencies, the federal agencies, like National Weather Service, National Resource Conservation Service. We've got the U.S. Geological Survey, all of the agencies that were involved in helping us to respond to these various hazards. Let's see what lessons we've learned so that we can then create a plan that moves forward in this particular space in here. And so one way of doing that is I'm going to suggest having a hazard coordinator that sits in the office of the Vermont State Climatologist that works directly with towns and municipalities. This is what I did with one of my classes 2 years ago, when we worked directly with the town of Underhill to assist in lifting up climate change in their local hazard mitigation plan. And having students directly involved is a great way to support this particular type of activity. And they can also serve as liaisons to the legislature and sort of support a lot of the exchange of information and knowledge. Another piece in here is we don't have enough measurements of how much rainfall, how much snowfall is actually falling across the state. And so I am one of the coordinators of the what's called the COCORAS program that measures precipitation in everybody's like backyard. And so it would be great if we could buy a rain gauge for more Vermonters to be able to measure how much is falling, so that we can do a better job with our forecast, a better job with ground truthing all of this that's taking place. And then the last thing is, how do we take those lessons learned and get it out to everybody across the state of Vermont? And so I was approached by a group in the United Kingdom called Research Futures. And what they are willing to do is to bring all of these lessons learned, maybe from the summit that I'm proposing here, bring it all together and package it into podcasts, into various elements of social media, into maps, into ways of getting that information out so everybody can access it and be able to understand that all of these hazards occur everywhere. All of these hazards we need to know about. And it's not just hurricanes that give us flooding, for example. How do we make sure all of those words and understanding get out there? So with that, I thank you again for the invitation to provide this information and testimony, and I'll turn it back over to our chair, Sheldon.
Thank you so much for that information-packed lecture. Do members have questions?
I do have. Thank you. Thank you, Doctor. Going back a ways in some of the maps that you had, you indicated Lyme disease has come further north, but Massachusetts had no color in the entire state. Do you know why?
It's probably because of how the data are being reported. So each state, the Department of Health, each state collects the data and then sends that up to the Centers for Disease Control. And if the data are not reported, then the Centers for Disease Control, CDC, don't have that information to put on the map itself. So I'm not sure what happened in Massachusetts, but I would suspect that the information exists and that there are massive Lyme disease cases across that state as well.
That's what I thought. Thank you.
My pleasure.
Actually, I have a question. I have a question. I'm curious about the sort of ability of the climate to recover in the instance that we potentially significantly reduce the amount of CO2 we were emitting and perhaps change some of our land use practices. Who's working on models that would help us understand the ability of natural systems to recover?
So I would say a lot of that is part of the National Climate Assessment, because what the NCA, as it's called, is designed to do is to do two things: look backwards to see what progress we've made, but also to project out to the future to see what are some of the scenarios, what are some of the storylines that could occur if we reduce greenhouse gas emissions by certain amounts, right? The Intergovernmental Panel on Climate Change is also doing the same thing. And one of the things that's important to understand is even if we stopped every single greenhouse gas emission into the atmosphere today, the climate would still continue to warm because of all of the gases that are already there. It's something called inertia. It's like when you step on the brakes, you don't stop immediately. You go forward a little bit and then you stop. That's what's taking place in the atmosphere right now. So even if every single greenhouse gas will never ever to be emitted, starting right today, the 3rd of January 2024, you'd still see the atmosphere warm a little bit because it has all those gases already in the atmosphere right now. And they're still doing what they do. So they're still absorbing radiation and giving it back out, causing the air to be warmer than it would be if they weren't there. So part of what the scientists who do a lot of the modeling are looking at is if we stop the gases, how much more would it increase by? If we are aggressive, how much that would it stop it by? If we're not aggressive, how much would that stop it by? So they're coming up with all of these ranges of what could occur. And that's where you hear things like trying to limit the warming to 1.5 degrees or 2 degrees. That's where they're getting those values from.
Thank you. Who did someone over?
I thought I saw Representative Pouch or Representative Burke. Okay, I thought I saw a hand.
Right. Thank you so much for your presentation. It was very edifying.
I hope it wasn't too much.
No, but
Because
I,
there's a lot of information to unpack in there.
I will say, as the facilitator, I looked down, thought 58 slides. I don't know how this is going to happen, but you did it. Thank you.
Well, some of them are intro slides, but thank you again for
Great.
the
Okay, I
invitation
guess
to be
we're
here.
seeing one question. Representative Burke.
I have a question. Thank you. Thank you so much, Professor. How do you feel hopeful or, I mean, you're working with this all the time. Do you feel, I mean, given that Vermont is not really, we're not even reaching our own climate goals, which is distressing. What are your thoughts? Or we ask you.
So people always ask me that question. They say, do you ever get depressed? How do you get out of bed in the morning? And yeah, I know. So I have a couple answers to that. The first one is every single day we learn a little bit more about our climate that we didn't know before. And that helps us to, it's like a jigsaw puzzle. It helps us to have one more piece of data or information or understanding that we didn't have that would allow us to make a slightly different choice or maybe tweak something that we're already doing. So that's one piece in the puzzle. We're always learning, we're always improving, the models are getting better, and we're having a better sense of what we need to do. The other thing that gives me hope, that gets me out of bed, is our young people. Because our young people have such a sophisticated grasp of all of the ins and outs of what's taking place on the land, but also what's taking place in the atmosphere. It is amazing to watch. And that is what gets me up. When I work with my classes, when I see all of these wonderful young people bringing not just their energy and their passion, their enthusiasm, but their understanding to the table, that's what keeps me going.
Thank you. That was a great way to end. Thank you so much for joining us.
No problem. Thank you. Take care.
And with that, members, I think we'll take a 5